Digital people.
Chapter 7. Hello friends. Today we are going to the discussion about continuous integration. Implementing continuous integration. Continuous integration is the process of automating the build and deployment process. This process encourages the developer to publish the code on the repository tool to confirm the code. In the open source project development world, the continuous integration is very well implemented using GitHub repository along with collaboration tools like Slack, open source communities, chat, etc. Here in this scenario, the developers start the project in their own machines. The most of it has the integration with GitHub repositories tool. Once the code has been developed, the developer deploys it on the branch folder with one-click build button on the I tool. The watchers of that repository are free to run the functional and security scan the code. The owners of that repository can review the code to publish and master. The watcher does the test and provides feedback to the developer from team communities. Also, each project is published with versioning. Some group might be happy with the version XXXX.0.1 to use it on production zone, while some other groups expect extra features in the next version XXXX.2.0. The benefit of this collaborative working culture is to encourage the developer to share code including test scripts in the common repository. This ensures the quality checks on the integrated code to get strong feedback. In the end, it delivers quality software to the end users. With this approach in practice, continuous integration will progress the next steps of continuous delivery. The continuous integration relies on three foundational elements such as version control system, continuous integration system, automated build process. Version control system. Earlier, the code versions used to control in folders and segregated based on environments such as dev, test and production by the VQ version control unit team. The developer had to follow the process in Excel sheets for approval and hand it over to VQ. Here, even if a developer makes small changes on the fly in any of the environment, then the respective changes require a manual commit to the VQ team. Due to this whole manual process, there was no concept of code sharing and packaging. Also, if person A do changes on login.jsp while person B has already done the changes on the same file, then it is complete VQ team responsibility to integrate the code for the deployment. Centralized version control system. To have all these processes automated, the organization implements centralized version control tools like TFS Team Foundation Server, SVN Subversion. In this centralized version control systems, code's maintained as a central repository. The centralized tools leverage the developer to check out the code for code changes and also check in into the branch for the code commit. Each pull and push requests of code will be synchronized into the centralized server. So if a developer does check out to his local machines, others will get a file change notification. These type of tools have the user interface maturity. To have a single repository to maintain the code and enable the code, the software configuration management team to have proper access control policy. The centralized version control system well suited for large base code that follows the waterfall method. Distributed version control system. The distributed version control system comes into practice when organizational changes its methodology from waterfall to agile. As the agile process is in place, the large code base divided into multiple the smaller code base. So each developer of the respective team can clone the common code into their own repository. GitHub is a current distributed open source repository tool where developers can fork any code from the shared repository. Also, it has a robust access control policy as the owner of the repository will have full control of the master node. Branching of code is very easy in this distributed format. Currently, Git is a famous repository tool in the open source world. All the ITs have the proper integration with Git. Also, the C tools like VSTS and Jenkins has the token method to access the Git. So Git features of clone, code commit, history, user stories and Git hooks are already available from IDE. Git automation. The GitHub has the special feature of Git hook which will perform client-side verification on the file before it gets committed into a common repository. so we can add a set of shell scripts to the client side to perform pre-commit verification. This feature helps the developer to scan sensitive information on a code, auto-fix the code alignments, rearrange the configuration file, remove unnecessary spaces in the code. Also with GitHub server-side verification functionality. It introduces the code review before the code gets committed and auto-merge. Continuous integration system. The DevOps process makes the organization succeed in terms of the quality product delivered to the customer in the fastest manner. Continuous integration is the executable approach that benefits the developer to perform a hassle-free development without worrying development environment design, platform certainty, release notes preparation, package management, unit tests, integration and test report preparation. The CI system takes care of steps from code build to code deployment. It also notifies the whole group about the result of the code that checked in recently. Automated build process. The main focus of the automated build process (CI) system is to encourage the developers to concentrate on developing the code with new ideas. Here are the features of the automated build process. Get the source code from repositories. Build a solution to compile the code. Pack the binaries for deployment. Deploy the project code to the CI server. Test execution as per the test case design. Publish the test or build a report to members of the team. Continuous integration tools behavior. There are many CI tools currently available in the market, out of which VSTS, Visual Studio Team Service, JetBrains TeamCity and Jenkins CI are the most popular tools used by many organizations. Most of CI system designed with agent and queue concept. So whenever the code commits in the repository tool, the CI system will start the build process of fetching the build from queue management. Then it dispatches the build configuration to the agent on the CI server for further execution. The CI tools come with plugins for Maven, Gradle, Ant, Misbuild, Junit, Pylint, etc. to ease automated build, unit test, functional test, and regression test and build definition. The tools ease the build definition using the WebIR files in the form of SIN or YAML files. The build definition generally consists of agent, environment variable, stages and steps to follow on each stage. Agent. The agent can be any of the local systems, virtual machines, containers or on the cloud. Environment variable. It has the values that globally used in each stage of the CI pipeline. Stages. Each stage shows the status of build, test, deploy and deliver the result. Steps. The steps on the stages they classify according to the goal of the stage. For example, the build stage consists of steps such as Msbuild, Maven build or even simple Unix shell, and Windows PowerShell script to compile the code. Moreover, the CI tools have many options to verify your build. It raises a notification with build status, and the developer to analyze the code, code comparison, the history of check-inches, and also provide the feature of in-tool digital approval. CI benefits. Improving code quality based on the instance test report. Auto-triggering or constant scheduling for automated testing upon every code change. Reducing build times for rapid feedback and early detection of problems. Risk reduction. Better managing technical debt and conducting code analysis. Reducing long, difficult, and bug-inducing merges. Increasing confidence in code base health long before the production. Monitoring the Cheeto incorporate the continuous integration in the pipeline of continuous delivery. The CI system should go through a validation process. Having that in mind, we need to measure our continuous integration system to go into the full mile of continuous delivery. Do the developers commit the code many times in a day into their repository tool? At least one commit happening on the branch node in the repository tool, to publish the code on the CI system. Whether CI have updated with proper auto-build trigger and auto-unit test scripts. Do the developers give priority to the unit test result? With the CI environment test result, whether developers improve the codes and fix. I hope This chapter should have given you the overview of CI system. If you are new to this channel, I would encourage to go through all the remaining chapter to learn more about DevOps.
Thank you!